Boston Dynamics just flipped the script on humanoid robots. For years, Atlas was the robot everyone watched doing backflips and parkour on YouTube. Viral videos, impressive stunts, laboratory curiosities. That era officially ended. Atlas is no longer a research experiment. It is a production robot heading to real factories. And the implications for work, labor, and the entire manufacturing industry just got very real. Let's watch the latest clip now. All 2026 Atlas deployments are already fully committed. Fleets are scheduled to ship to Hyundai's Robotics Metaplant Application Center in Georgia and Google DeepMind in the coming months. By 2028, Hyundai plans to build a robotics factory capable of producing 30,000 Atlas robots per year. That number is staggering. 30,000 humanoid robots per year. And Hyundai is not building them for sale. The company is building them to work inside its own factories. The way Atlas learns tasks represents a fundamental shift in how humanoid robots operate. Boston Dynamics is no longer hand programming every single movement. Instead, they are training Atlas almost like teaching a human worker. The robot observes, it practices, it fails, it improves over time using artificial intelligence. In a recent blog post, Boston Dynamics explained how they trained Atlas to lift a mini fridge and carry it to a worker. The task sounds simple: pick up a fridge, walk with it, set it down. But for a robot, that task requires strength, whole body coordination, and the ability to adapt to variables like weight distribution, grip friction, and shifting balance. A human learns this through physical experience. Atlas learns it through reinforcement learning in simulation. The training process starts with a reference trajectory. That can be teleoperated demonstration, an animated sequence, or an abstract goal. For the fridge move, Boston Dynamics started with a simple animation allowing Atlas to take full advantage of its superhuman range of motion. Then they set an objective for the robot. Stay as close to the animation as possible. Complete the task even when pushed, pulled, or disturbed. Atlas practiced the move for millions of hours in simulation running in parallel on graphics processing units. Through extensive experience in simulation, Atlas learned to adapt its behavior to many variations of the fridge. Different weights, different locations, different amounts of grip on the ground, and with the fridge. Once the simulation looked good, they tested on hardware. Boston Dynamics has always followed a build it, break it, fix it philosophy. Simulation only takes you so far. Testing on hardware is how they make things better. The real breakthrough is how small the sim-to-real gap has become. The discrepancy between a policy's performance in simulation and its performance on real hardware used to be massive. Assumptions and mathematical simplifications in simulation fail to capture the true complexity of the real world. Boston Dynamics has closed that gap dramatically. If a behavior looks good in simulation, it looks good on the robot. What you see in sim is what you get in reality. How did they achieve this? High-fidelity hardware. The new Atlas uses only 2 types of powerful, highly efficient actuators and is fully symmetrical. That simplicity means they can model the robot with incredible accuracy in simulation. Domain randomization also plays a critical role. Boston Dynamics does not train the robot in a perfect world. They vary parameters like the weight of the fridge, the friction of the floor, or the strength of the motors slightly throughout training. Small random variations throughout the training robustify the final behaviors to real-world variability. The result is a robot that can be trained on new tasks in under a day. That speed changes everything about how humanoid robots can be deployed in factories. Instead of spending weeks or months programming a robot to handle one specific task, companies can train Atlas on a task quickly, deploy it, and move on to the next challenge. Companies everywhere are racing to build humanoid robots because factories are struggling with labor shortages and rising costs. Manufacturing work is physically demanding. Many tasks involve repetitive motion, heavy lifting, and environments that are uncomfortable or dangerous for humans. Warehouses operate in triple-digit temperatures. Assembly lines require workers to perform the same motion thousands of times per shift. Construction sites expose workers to hazardous materials and unstable structures. Humanoid robots offer a solution. They do not get tired. They do not need breaks. They can work in extreme heat or cold. Atlas is designed to operate in industrial environments ranging from -20 degrees Celsius to 40 degrees Celsius. The robot can lift up to 50 kilograms, 110 pounds. It has 56 degrees of freedom with fully rotational joints. The robot autonomously swaps its own batteries for continuous operation without downtime. Hyundai plans to begin deploying Atlas in its factories, starting in 2028, initially for parts sequencing tasks. By 2030, the company expects Atlas robots to move into component assembly with a longer-term plan to take on tasks involving heavy loads, repetitive motions, and complex operations across production sites. Hyundai Motor Group has committed its entire 2026 Atlas production run exclusively to internal deployment at its Robotics Metaplant Application Center and to Google DeepMind. The RMAC facility functions as a data factory. It is designed to build the world's most complete dataset for training humanoid manufacturing skills. Robots will learn sequencing, assembly, and logistics tasks in a controlled setting before being deployed at scale. That dataset is what Hyundai will use to train subsequent Atlas generations and to compress the time required to deploy a robot on a new task from weeks to days. Boston Dynamics is also partnering with Google DeepMind to integrate cutting-edge AI foundation models into Atlas. The partnership will work on developing robot AI foundation models that could unlock capabilities far beyond current industrial tasks. DeepMind will use Atlas as a platform for training foundation models, essentially large behavior models for general-purpose humanoid intelligence. Boston Dynamics is entering a massive humanoid robot race alongside Tesla, Figure AI, Apptronik, and Chinese robotics companies. But Boston Dynamics has a major advantage. Hyundai owns the company, supplies the parts, operates the factories, and plans to manufacture up to 30,000 Atlas robots per year by 2028. Unlike experimental robots of the past, Atlas is now being built for real industrial work. Atlas is far more advanced than many competitors, with greater strength, flexibility, and precision. The robot recently switched to an all-electric design, making it more reliable and practical for factories. It can work autonomously, follow tablet commands, or be remotely controlled by operators. The bigger story is what this means for the future of work. Companies say these robots will help solve labor shortages and handle dangerous jobs, but many fear millions of jobs could eventually be automated as humanoid robots become cheaper and smarter. After more than 30 years of robotics development, Boston Dynamics is no longer building robots for viral videos or backflips. Atlas is preparing to become a real worker. The humanoid robot era is no longer science fiction, it's starting now.